If you're watching this video, then there is a good chance that you were taught at school that the Earth is round. And since we have pictures from space, everybody who has common sense agrees that this must be true. Now take a close look at the roof of the house. You probably think that it looks straight, but if you really want to know, there is an easy way to find out. If you want to make sure that the magnification is even across the whole frame, the lens needs to be perfectly curved. The sides of the building will be smaller than the center. You can still see the walls in the background, but they appear much larger than when you don't look through the roll. This is what a typical camera lens does to the world. It corrects for converging parallel lines, but at the expense of the overall image being distorted. This is because light rays coming from the edges of the building don't converge at the vanishing point, but rather behind it. This is called converging parallel lines. If the Earth was flat, you would expect the ship to just get smaller and smaller. Remember how I said that the distortion caused by the lens makes things smaller in the center of the frame? Well, this effect is used by astronomers to determine the size of distant objects. It's amazing how something as simple as this can be so complex. If you enjoyed this video, then make sure to hit the subscribe button. Thanks for watching, and I'll see you next time. For example, the apparent size of the sun and the moon in the sky is very similar. We know that the diameter of the moon is about 2,158 miles. If the Earth was flat, you could measure the angular diameter of the moon in the sky and calculate its size using basic trigonometry. The result you get, however, is a value so large that it contradicts everything we know about the universe. This is because the Earth is curved. The angular diameter doesn't tell you the actual size of the moon. It tells you the size of the moon as seen from the surface of the Earth. The smaller the apparent size, the further away the object is. However, we know that ships disappear hull first and then the mast is the last thing you see. This is because the Earth is curved, and fortunately for flat earthers, this is not true. There is no distance on Earth where parallel lines converge to a vanishing point. First, you could travel along a road and measure the distance traveled and the change in latitude. They would appear to meet in the distance because the Earth is curved. If you did this, you would find that 1 degree of latitude is about 69 miles. This is roughly the circumference of the Earth divided by 360 degrees. Which makes sense because that is how many miles are in a circle around the Earth. If the Earth was flat, you wouldn't be able to consistently travel along a road without eventually turning. This is because there would be a vanishing point where the road would end. If you walk far enough along a straight road, you will eventually circle back to where you started. This is because the Earth is a sphere. Vanishing points and converging parallel lines only happen on flat surfaces. On a flat surface like your phone screen, they will not line up correctly. To correct for this, camera lenses are curved in such a way that parallel lines stay parallel. This means the building on the sides of the frame will appear larger than in the center. However, the overall image will look distorted. This means if you take a picture of the vanishing point, where the two sides of the roof meet, everything beyond that point will be smaller than what you can see with your own eyes. This is called distortion. The more you zoom in, the more distortion there is. If you grab a piece of paper and place it down on the ground so that it lines up with the roof, you can then walk further away from the house. When you do this, you will notice that the roof starts to curve downwards. This is what we call a vanishing point. However, some people claim to prove that these pictures are fake. Well, if you take a picture of something, all the light rays that bounce off of the object go through your camera lens and get projected onto your sensor. This is essentially a big chip that captures the light. The better the quality of the sensor, the more pixels it has, the sharper the picture will be. But this projection always happens upside down. This means if you take a picture of your roof, it gets flipped the other way around. So if you put the paper down like before and then take a picture of it, you will also see that the roof now curves upwards. This is because the light rays bounce off of the roof and then pass through the lens, which projects it onto the sensor upside down. Flat earthers say if the Earth is really a globe, why don't we see more curvature when taking pictures with a drone? This video will help you to understand how exactly camera lenses work and how they distort reality so you can answer this question yourself. We are going to use this picture of a van parked in front of a house. So how does this relate to the Earth being flat or round? Now here is where things get interesting. Camera lenses are curved, and they magnify things by projecting them onto your sensor bigger than they actually are. The reason for this is that if you take a picture of a building with your phone, which has a flat screen, the image will be distorted. It's similar to looking at the world through a toilet roll. You might have heard that the Earth is only 250 miles wide, and that the horizon only appears curved because of this lens distortion. There are a couple of ways to verify this. Another way to prove that the Earth is round is to track ships when they sail over the horizon. Let's go back to our picture of the house. This is why if you were on a flat surface, parallel lines would converge to a vanishing point. I bet you didn't realize that there was so much math behind taking a picture of a house.